really excited for today's video because it's going to be covering graphing two-variable linear inequalities. And like I've talked about before, math people are not very creative with their naming conventions. So if we look at graphing, that means we're going to be graphing something on a graph, most likely. Two-variable means that we're going to be dealing with x's and y's, most likely. Linear means lines. And inequalities means not equal to. So we're going to be graphing linear inequalities, which means something where there's going to be some shading involved, but we're still going to be dealing with x's and y's. And what's really nice about that is it's actually a mixture of skills that we've already mastered. So on the left side, it's just graphing lines using slope, intercept, point, slope, standard form. All of that is going to stay. None of it's going to change. And then graphing inequalities, we used to graph them on number lines, shading either left or right with open circles and closed circles. Now we're going to be shading them on these two-variable Cartesian coordinate planes. So let's jump right into it. Let's graph the inequality y is greater than 3x plus 4. And like we used to solve this, we are going to pretend for a second that there is no inequality symbol at all. So we're going to be graphing y equals 3x plus 4. This is written in slope-intercept form, y equals mx plus b form. Therefore, our m has to be 3, or 3 over 1 for our slope. Our b value is going to be 4, or the ordered pair 0, 4. And we're just going to graph that just like we've been forever. So here's our b value. We're going to make our slope by going through all of these points. And I'm going to go back down because when I'm graphing on a computer, it's actually really helpful if I have more of the points drawn. And now I'm going to try really hard to graph straight through all of these points. That was actually not bad at all. And there we have our inequality. Or we have our equal sign. Now, we have to graph it as an inequality, which means y is greater than. So if we remember, greater than or less than was an open circle before. And greater than or equal to or less than or equal to was a closed circle before. Well, now it's going to be a closed line. And we can't have an open line, so it's going to be a dotted line. So we do not have the equal sign underneath. So we are going to make our line into a dotted line. Which means that nothing that's on the line counts as being shaded. So it has to be over or greater than the line. So what I do here is I pick a single point. So I'm going to go right here. Greater than, you go above that point. Less than, you go below that point. So we want greater than. So I pick my point, which is right here. And I'm going to go greater than it, which is right up here. And I'm going to shade everything in this region. And it seems like everything we covered there is something that we've covered before, at least partially. And what's crazy to say is we're actually done. That's the whole thing right there. We just graphed our linear inequality. But before we get too far ahead of ourselves, I want to talk about why do we shade above when it's greater than a single point and below when it's less than? Well, I picked 4 points on my graph. Okay, so I have them labeled over here on the left side. And I want to just plug each of these points into the inequality and see if it makes a true or a false statement, remembering that our x is our first point and our y is our second. So for the first ordered pair, which is right here, I want to graph or plug in 3 and 3. So I end up getting 3 is greater than 3 times 3 plus 4. Well, this is 9 plus 4 is 13. So this is a false statement. So I'm going to go over here and I'm going to put a false right there. Now let's plug in the point 1, negative 4. So that becomes negative 4 is greater than 3 times 1 plus 4. That's 3 plus 4 is 7 Negative 4 is not greater than 7, so this one is also false. False over here. For the points down at the bottom, I get 0 is greater than 3 times negative 7 plus 4. This is negative 21 plus 4 is negative 17. 0 is bigger than any negative number, so that makes this one true, which is right here. And finally, 8 is greater than 3 times negative 3 plus 4. Negative 9 plus 4 is negative 5. 8 is bigger than negative 5, which makes this one also true. And now I'm going to shade where the true statements are and not where the false statements are. So that's why I shade up above the line when it's greater than. All you're doing is shading all of the ordered pairs that would make this statement true. It means if I picked any ordered pair in the shaded region and plugged it into my equation, it would make the statement true. The dashed line here means that I cannot pick a point that is on the line. If I had a line underneath here, calling it equal to, then I could pick points on the line. So let's do a couple more examples here where I just have to graph my line and then shade above or below that line. For my first one, I have this in point slope form. Point slope form, if you remember, is y minus y1 equals m parentheses x minus x1. Therefore, we can find a point and the slope and use that to graph our line. So the point here would be negative 3 for our x, because it has to be opposite because of that negative sign. And our y is going to be negative 5, because once again, must be opposite. And our slope is negative 5, or negative 5 over 1. From here, I'm going to graph my ordered pair first, which is negative 3, negative 5, right there. And now I'm going to use my slope to graph as many points as I can. So there's my line, and let's hope Mr. Schmidt can pull this one off as well as the last one. Not horrible. And because the shade is underneath, this will stay as a solid line. But this time I'm going to graph underneath, or less than. So what I do is I pick a single point. I'm going to pick right here. And I want to shade directly underneath that point because it's less than, which means I'm going to shade underneath that point. So everything less than over here. So all of this is shaded. Once again, means I could pick any point from in the shaded region, plug it into the equation, and it would make a true statement. Let's do one more. For this equation, I need either to make a table of values, like I've done many, many times before, or I can write it in slope-intercept form. And I'm going to write it in slope-intercept form because I know that's faster. So from here, I'm going to subtract 3x because I want to get my x's by themselves. I have negative 4y left on the left side is greater than. Boys and girls at a dance, so they can only stand next to each other. You guys laugh, but when you're in high school, you're not going to forget that. Now I'm going to divide everything by negative 4. Now, here's something many of you have probably forgotten. We divided by a negative when there is an inequality sign, which means I need to flip the sign when I divide by a negative. I have negative 3 and negative 4, so I'm going to write that as 3/4 x. Positive 8, negative 4 makes this negative 2. So I have y is less than 3/4 x minus 2. From here, I pick my m and my b, and I use them to graph as many ordered pairs as I can. So I'll graph those in green. I shade up 3 and over 4. up 3 and over 4. Let's go down 3 and back 4. Down 3 and back 4. So far, I haven't messed this up. Let's see if this is our first one. Not too bad. Look at that. Now, this time, oops, not a great arrow, we have just greater than, which means that we need to make this a dashed line. Some people are really good at making dashed lines as they draw the line. I'm not one of those people, so I always just erase after the fact. And now I need to graph less than because I had to flip the sign. So I pick a single point. I'm going to pick up here this time. And I want to go less than or below that point, which means I'm going to shade everything down in this region. And that is everything with graphing two variable linear inequalities. As always, if you have any questions, please let me know.